All right. Okay. So I think now the screen is shared. All right. So let us begin. So we will just start with a basic recapitulation of what we have already discussed till now. So I guess everybody must be remembering at least little of what we discussed in the last class. Avirup, isn't it? Remember little? Acha. So we will utilize it and we will like have a, brief idea about what we have discussed till now. So let us suppose there is let's talk about heart. So if you look at our heart, like there is a like basic structure. If I talk about, so let us say this is a basic structure. What are the parts which are present? So number one, we are going to have the superior vena cava. This is going to be the right atrium, and this is going to be the ventricle part. Okay, this side there will be the right ventricle, that side there will be the left ventricle. Now we are talking about the major ventricular depolarization. Okay, so if we talk about the major depolarization, major ventricular depolarization, you understand that the vector will be in this direction. We accomplish this word that the major ventricular depolarization vector কোন দিকে থাকবে, it will be towards the left side of the ventricle, है ना? Now if you try to understand what we have discussed till now, so we have to like first thing that we have to do is we have to establish the axis, the lead. And you remember lead means circuit. That means I can say that this was lead 1. If this was lead 1, then lead 2, which is the main lead I told you, that moves leftward. So that means this is going to be the lead 2. This is lead 2. And similarly, this is supposed to be the lead 3. These are the three leads which are present. That means if you want to know the potential difference between these two, so that is lead 1. You want to know the potential difference between these two, it's lead 2. You want to know the potential difference between these two areas, that is in this direction, that means it is lead 3. Now along with that, what else do we know? We also know that we could see it from almost like 90-degree. How? So accordingly we can have here, which one is this? This one is AVF. Okay, it's the augmented voltage for foot. Then what else we have learned? We have learned that this one is augmented voltage in the left arm, and then we also have learned that this one is augmented voltage in the right arm. Hana? So we have learned till this much. So these are the limb leads that we have learned till now. But the issue is this, that how do we actually use it? Now try to understand this thing, that see, if you look at the, let's say if I draw this heart once again, let's suppose this is the heart, and suppose the direction is this. Now how will lead 1 observe it? So where was lead 1? So here is lead 1. So, if you remember your intermediate class about how you used to draw or how you used to do vector analysis, anytime vector analysis. So, I hope you will be remembering that you had to drop perpendiculars. So, you drop perpendicular, you drop perpendicular. Can I say this is the component? What do you think? If I talk about lead 2, so this one was lead 1. If I talk about lead 2, so lead 2 goes like this. So if lead 2 goes like this, and if I have to draw perpendicular, then do you realize that the perpendicular will be this? Agreed? Yes or no? Okay. We are dropping perpendicular on the lead to check the vector, the magnitude and the direction. So let's talk about lead 3. So this is lead 3. So if this is lead 3, then what are we supposed to do? We have to drop down the perpendicular like this. So this is going to be the vector. If you observe it, you will notice that all the three vectors, their magnitude is a little bit different, isn't it? The magnitude is not same for all. That means if you look at vector 1, like I mean lead 1, if you look at lead 1, so you will see that lead 1, when we look at the vector, so and also if you remember, this one was positive and this one was negative. This is what we learned in the last class. So you see, in this case, lead 1 is like it is a depolarization moving towards the positive electrode. Lead 2, same thing. You see, depolarization moving towards the positive electrode. This is positive, na? Wandering electrode, I told you. And in lead 3 also it is the same case. All are moving towards the positive electrode. That means major ventricular depolarization, if we talk about it, then do you realize that major ventricular depolarization is supposed to be a positive reflection in any case? Correct or wrong? Yes. But if we talk in a different way, so let us suppose, I'm just making it very like a simpler picture now. So let us say that I have this as the cardiac triangle and the depolarization is moving in this direction. But this time I want to, I am the observer lies over here. The observer lies over here. So where is the observer? The observer is the AVF. ठीक? So you tell me that if you drop perpendicular, then the direction of the depolarization is towards the anode or it is away from the anode? Towards the anode হচ্ছে. Now, if I say, if I talk about, let's say this one was AVF. Now that means if I say AVR, okay, if I say AVR, that means let's say this is the direction of AVR. So this time observer is here. So if you drop some perpendicular, whatever it is, if you drop perpendicular, so the direction of depolarization is moving away from the anode or it is moving towards the anode. AVR. Major ventricular depolarization is, because see, if you talk about this one, let's say if you have to drop perpendicular from here, like in any way, so the arrow is going to be away. Observer is on this side and it is anode is on this side, but depolarization direction is on this side. Everybody getting it? So that means I can say that for AVR, this is not going to be a positive deflection, it will be a negative deflection. Okay, now another thing. If we talk about this lead AVF, that means it is going to be a positive deflection. Rule of thumb: lead 2, lead 2, lead 3, and AVF. Do you realize that they are essentially going to have a positive deflection? Because common sense, lead 2 is also directing downward, lead 3 is also directing downward, and AVF is also directing downward. Okay, but if we talk about AVR, AVR is going to have a negative deflection for major ventricular depolarization. We are talking about the main peak. That is actually the R wave. Okay. So till this much, everybody is clear about it. No confusion. I think Devushmit is also there today. Acha. So, okay. So let's see how much you have understood, whether you have at all understood or not. Okay. So I'll consider a situation. Let's say this is the cardiac triangle in which this is the direction. Now, you are going to tell me that I have made lead 1, lead 2, and lead 3. Only these electrodes. I have made lead 1, lead 2, and lead 3. So you tell me that first let's talk about atrial depolarization from here, atrial depolarization. So you are going to tell me atrial depolarization from lead 1, if you think about that. So what are you expecting? Positive deflection, negative deflection. I'm talking only about lead 1, mind it. Positive deflection, negative deflection, what kind of thing? You know, this is negative, this is positive. And we are talking about which lead? Lead 1. So for lead 1, you tell me P wave. How should be the nature of P wave? Positive, negative, and huge magnitude. Magnitude should be big magnitude, tiny magnitude, moderate magnitude. Tell me. Moderate magnitude a positive হচ্ছে. So I can draw it like this, correct? So tell me what should happen to lead 2. Now we are talking about lead 2. So in lead 2, P wave nature একই হবে. Okay, it should be same. Positive. Okay. Talk about lead 3. Lead 3 magnitude বেশি লাগছে. Okay. So like this is bigger, or you think this should be bigger? But it should be positive or negative? Hmm. Lead 3 te ki hai? Let me remind you what happens in lead 3. In lead 3, this one becomes negative and this one becomes positive. Huh. So now accordingly answer me. Perpendicular ta negative distance. Perpendicular negative. Think about the direction of the vector. Look at the direction of the vector. The direction of the vector should be A or direction of the vector should be B. What should I draw on lead 3? A হচ্ছে না তো direction of the vector is towards anode or away from anode. So if it is towards anode, so deflection should be positive or negative. Simple. What is confusing over here? So deflection is positive. Agreed? Okay. So this part is clear to all. Now let us think of the same thing, but this time we will look at it about the major ventricular depolarization. So first think about major ventricular depolarization in lead 1. In lead 1, what will happen what is going to happen during the septal depolarization? You remember septal depolarization? Septal depolarization, remember or not? হ্যাঁ, so think about the septal depolarization from lead one point of view. Lead one point of view. Fast, fast. Take your time, but actively think. You have simple thing. Draw perpendicular. That's it. So for this purpose, keep a pen and paper. So drop perpendicular, na? What is the problem in dropping perpendicular on the axis? See, I have dropped the perpendicular. Is it visible on the screen? So at least now tell me direction should be what, on left side or right side? Vector direction this way. বোঝার কিছু না, I'm just asking what should be the direction of the vector. I don't know, like he said it. Tribal, what is your opinion? Right side or left side? বোঝার কিছু নেই, direct look at the direction of the vector. হ্যাঁ, তো right side or left side? Towards cathode না? So cathode is on right side or left side? On the left side. So fine. What is the confusion here? Is it confusing or you are understanding? মানে ভেক্টর করা হয়েছিল কি এর আগে? ভেক্টর একটা বেসিক কনসেপ্ট। এই হচ্ছে ম্যাগনিটিউড। আমি এখান থেকে দেখছি। আমার এই কম্পোনেন্টটা চাই। ফ্রি বডি ডায়াগ্রাম। হ্যাঁ? হ্যাঁ। তো cos থিটা করে করবি কি করে? লাইক আল্টিমেটলি তো ইউ হ্যাভ টু ড্রপ ইট ডাউন। তাহলে আমি যদি এখানে ড্রপ করি তাহলে ভেক্টর থোড়ি না এরকম আসবে। I think this is very simple. Like, suppose there is a hill, and suppose this is a object present. So when the force is applied in this direction, so there will be one component which will be working in this direction, na? And like, how do you know? Like, you have to drop a perpendicular on the plane. That is the basic idea. হ্যাঁ কি না? So this is the only concept that we are working with right now. There is no formula, there is no calculation, nothing. We are just following a simple concept. Okay, so fine. Tell me, uh, lead one. That means we are getting positive deflection or negative deflection. I think everybody should participate also. Otherwise, you will not understand. Towards negative, so negative. Okay, so it is negative lead one. Now, same concept apply for lead 2. So what is the plane for lead 2? What was the axis for lead 2? How was the lead 2? How was the lead 2? এরকম or এরকম? Lead 2 is, see, it is on the screen. Lead 2 is going like this. On the screen it is written. Okay, let's put it in this way. Lead 2 is from left arm to left leg or right arm to left leg. Then fine. Okay, so this one is going to be the right arm. This is the left arm, and this is the left leg. So that means it is moving from right arm to left leg. Then fine, huh? Because there can be a mirror concept in our video. So fine, okay. So right arm to left leg. So this part is clear. So right arm to left leg, mane, this should be the idea. So now tell me direction of the vector. Hmm. Rest of the people, do you agree or disagree? Agree? Okay, correct. So negative deflection. So lead 2 also negative deflection. All right. Now think in the same way about lead 3. Yeah, negative, and this one is positive. And what about the vector now? Negative হচ্ছে, correct? So negative হচ্ছে. All right. Now let us think about, so this is, so we are clear about P wave, we are clear about Q wave. Now we have to think about the R wave, actually, the real major ventricular depolarization, like that middle picture that I have drawn. Now you talk about it and tell me what is your expectation about lead 1. Major ventricular R wave, major ventricular depolarization. Middle picture orange. Huh. Rest we have done. Na? This one was done already. Acha, lead 1 positive. And what about this thing? Magnitude in lead 1. Agreed, everyone? Magnitude should be little bit less. है ना? Because, okay. So let me use some different color. Okay. Let's drop perpendicular. This is the magnitude. In vector, length determines the magnitude. So if you compare it with, say, lead 2, what do you think? Is the magnitude remaining same? হ্যাঁ, তো সেটাই ও বললো. Now agreed? That means I can put it somewhat like this. है ना? What about lead 2? What can you comment on in the same way? Okay, so positive, positive, বেশি. So lead 2. And what about lead 3? Acha. Okay. So like this. Correct? Clear? All of you? Now think. Let's talk about the next part, that is basal depolarization, three phase, right? This one is the R wave. So tell me about the S wave. What is the direction of basal depolarization? The basal depolarization was happening over here, left picture. Mm-hmm. Mm-hmm. All right. So let the others think a little bit. Rest of the people, what do you think? Do it. Oh, acha, screen sharing is gone. Ja. Okay. Now I can see, na? Hmm. 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 Yes. So direction of S wave should be, yes. This is the direction of S wave. So think about it. So it should be towards the anode in cathode. Okay, then all three. Okay, so let's do it. So that means here it is going to go like this, here it is going to go like this, and here it is going to go like this. Understood? Is it very difficult now? Think on it. No. So now finally we will talk about the repolarization. So let us talk about repolarization now. So what is the direction of repolarization? Like I told you, last to depolarize will be first to repolarize, है ना? So direction should be this way. So you tell me what should be the idea? Correct. মানে তিনটেই negative. Negative. Okay. 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 One thing, remember. Repolarization is electropositivity or electronegativity. So electronegativity moving towards anode. বলার কিছু নেই. Observe it. It is in front of you. This one is electronegativity. Till this much, whatever we have discussed, what were they? They were all Yes, there were electropositivity, but this time now we are discussing electronegativity. So you tell me, what should be the type of deflection? Huh, so it should be positive deflection. Agreed? Agreed or not? Okay, Orchita, you have understood? Okay. What was the rule? When depolarization was going on, gradually one by one by one by one, all the cells were becoming electrically positive or negative? Positive. So তার মানে when there is a depolarization wave, so it is a wave of electropositivity or electronegativity? Positivity. But when there is repolarization, উল্টোটা হচ্ছে, so it is a wave of electronegativity and negative electronegative charge moving towards the negative electrode. So galvanometer, how does it work? It deflects উল্টো দিকে। উল্টো দিকে মানে correct. So negative moving towards negative is gives you positive deflection. So all the three are going to have positive deflection. Got it? So in the ECG, actual ECG sheet, you will actually be able to observe this lead 1, lead 2, lead 3. Got it? So since you have understood till this much, now let us make it more complicated by putting the augmented lead. I don't think it is difficult. You are doing it good. So augmented, you remember, augmented is located in these areas. है ना? AVR, AVL. This one is AVR, AVL and AVF. না না লাস্ট ক্লাস পড়লাম যে অগমেন্টেড যে ওর তো অনেক বড় কনসেপ্ট ছিল উইলসনস ট্রায়াড উইলসনস কমন টার্মিনাল ইফ অল দ্য কি বাড়ছে না কমছে মানে ইটস বাড়ছে তো বাড়ার জন্যই তো অগমেন্ট করা হচ্ছে হ্যাঁ তো think about AVR. So think about AVR. Mane, where is the observer? Here. Here is the observer. Keep it very simple. Think you are the observer. You are standing at AVR. So you think in this way, I'm helping you. This will make your job easier. You are standing at the AVR position and you are observing the depolarization wave. So you tell me, depolarization wave, you are seeing its mundi or you are seeing its tail? You're seeing the head of the tail of the depolarization. Na? That means it is moving out towards you or away from you? Away from you. And last class we discussed this, na? That there was a Wilson's common triad that was giving the zero charge. And then there was one positive charge moving in three position, the wandering electrode. So center was zero. Center to right arm. Center to left arm. Center to left leg. Remember? So, from that point of view, try to answer this. You are that positive charge. You are the anode. You are observing it. You are standing at AVR position. AVR position. So, the depolarization is moving towards you or away from you? Away from you. When P wave is going on, है ना? When P wave is going on, it is moving away from you. So, P wave in AVR should be positive, negative, multiplicative, divisive, positive. Why? If it is not positive, then it should be negative. Tell me why. Okay, rest of the people, what do you think? Repolarization, we are talking about once again AVR, we are starting from SA node firing. P wave. P wave. So it is P wave is moving away from you or P wave is moving towards you. মানে the depolarization. Two people have answered away. Two are left. Acha, okay, away. One is left. P wave. SA node firing. SA node কোন দিকে যাচ্ছে? SA node যাচ্ছে towards apex না? আর অবজারভার কোথায়? Where is the anode? তাকিয়ে যেদিকে তো অবজারভারের পজিশনটা কোথায়? Where is the এফ কোথায়? কি লিখেছি আমি? এভি কোথায় গোল করেছি? সি লুক এট দ্য স্ক্রিন না? AVR we are talking about. হ্যাঁ, তো away না? তো focus. So it is moving away from the observer. So that means in AVR, P wave should be positive deflection or negative deflection. Okay, rest. Negative. Correct. So fine. So let's put it negative. So this one is negative deflection. Now similarly, P wave. Similarly, P wave, but this time observers are standing at AVL. The anode is at AVL. Now you tell me. You two words. So তার মানে it should be positive or negative. Okay, once again, you are standing at AVL. You are looking at the depolarization. You are looking the mundi or you are looking at the tail. Tail দেখছিস? Like, you are standing. মানে টেল যখন তুই তাকাচ্ছিস, ডোন্ট ইউ থিঙ্ক কি ততক্ষণে দ্য এন্টায়ার ডিপোলারাইজেশন হ্যাজ রিচড লাইক দ্য এভি নোড? তখন আমার দেখে লাভ কি? when SA node is firing at that moment, when atria is depolarizing, charges are moving, so at that time you look at the head or you like, if there is a train moving in this direction and you are standing over here and the train is moving in this direction, you will never be able to see the head. But if the train is moving in this direction, you're standing here, will you be able to see the head of the train? So simple. Why are you complicating it? It is very easy. So you are standing over here and the train is moving in this direction. So when the train, you are seeing that, you are saying you will be able to see the tail. Of course, you will be able to see the tail of the train. But by that time, the train has reached a different station. We are talking about when the train is moving, when the train is passing. So the train is coming in towards you or away from you? Towards you, na. So that means the deflection should be what kind? Positive deflection. Yes, so simple. You're doing it all correct. Why are you confusing? It's positive deflection. Now, suppose if it is towards the foot, this time let's talk about the foot. AVF. Archita's first take or AVF. P wave. The upper arrow. Purple arrow. So purple arrow moving towards it, away from it. Positive deflection, negative deflection. सीधी बात. হ্যাঁ, কম্পোনেন্টটা শুন না, towards you না, বাস দ্যাটস ইট। তো পজিটিভ রিফ্লেকশন আর নেগেটিভ রিফ্লেকশন, where is the angle? নেগেটিভ চার্জ থেকে কোথা থেকে আসছে, এইটাই হচ্ছে কমপ্লিকেশন। আমি বলছি কমপ্লিকেটেড করতে না, আই এম কিপিং ইট ভেরি সিম্পল। অ্যানোড লাইক অবজারভার ইজ দ্য অ্যানোড আর অবজারভার ইজ দ্য ক্যাথোড। আমরা কনভেনশন কি নিয়েছি? Observer is the anode. You are the observer, you are the anode. আর আমি কি শিখিয়েছি যে ডিপোলারাইজেশন যেটা, think of it কি you are looking at its mundi or you are looking at its tail. बस, तो your anode train is, this is the positive train, so positive train का mundi you are seeing, it is moving towards you or its component is moving towards you, so deflection should be positive or negative. बस, तो deflection should be positive, do it, so simple. Difficult or easy? Let's see. So tell me about now the major ventricular defect. Yeah. ওকে, আচ্ছা, তুই লাস্ট ক্লাসে ছিলি না না? তো তাহলে কি অসুবিধা হচ্ছে বল? ওকে, সাপোজ এটা হচ্ছে আমাদের ট্রায়াঙ্গেল, এইটা হচ্ছে ডিরেকশন, এইখানে আমার অ্যানোড রয়েছে, ঠিক আছে? তো অ্যানোড থেকে দ্য ডিপোলারাইজেশন ওয়েভ দূরে চলে যাচ্ছে না টুয়ার্ডস দ্য অ্যানোড আসছে? তো যদি ডিপোলারাইজেশন ওয়েভ অ্যানোড থেকে দূরে চলে যায়, দেন দ্য ডিফ্লেকশন শুড বি পজিটিভ আর নেগেটিভ? নেগেটিভ হবে, নেগেটিভ হয়েছে। অ্যানোড আর ওখানে নেই, ফরগেট ইট। এবার অ্যানোড ইজ লোকেটেড হিয়ার। এবারে এর ডিপোলারাইজেশন ওয়েভ বা তার কম্পোনেন্ট ইজ মুভিং টুয়ার্ডস দ্য অ্যানোড না অ্যাওয়ে ফ্রম দ্য অ্যানোড? তাহলে ডিফ্লেকশন পজিটিভ না নেগেটিভ হয়েছে? ওকে, again forget it and think ki now the anode is here, তাহলে what should be the deflection type? তুই এখানটা দাঁড়িয়ে রয়েছিস, পজিটিভ যেখানে দেওয়া রয়েছে, ডিপোলারাইজেশন ওয়েভের যে অ্যারোটা রয়েছে ওটা একটা ট্রেন, তুই ট্রেনটার মুন্ডুটা দেখতে পাবি না লেজাটা দেখতে পাবি শুরুতে? তো হলো তো, তো তাহলে পজিটিভ রিফ্লেকশন না নেগেটিভ রিফ্লেকশন? ডান, ইউ ডিড ইট। ক্লিয়ার? ক্লিয়ার কিনা বল? ওকে, সো fine. Let us proceed ahead then. What about tell me about similarly septal depolarization. Tell me about septal depolarization. The septal depolarization টা কিরকম ছিল? Do you remember septal depolarization? Initially, this was the thing that we were discussing about. এবার septal depolarization টা towards AVR হবে না towards AVL হবে না towards AVF হবে? Septal depolarization কিরকম ছিল? কারেক্ট, তো সেপ্টাল ডিপোলারাইজেশন এরকম টাইপের ছিল। অল রাইট, সো টেল মি, you know the game, you know the drill. এটা হচ্ছে সেপ্টাল ডিপোলারাইজেশন। তো সিম্পলি টেল মি, এভিআর, অবজারভার ইজ অ্যাট এভিআর যেভাবে শিখিয়েছি, সো ইট শুড বি পজিটিভ নেগেটিভ। হ্যাঁ, ওকে, ওকে, গুড, হ্যাঁ, এভরিবডি পার্টিসিপেট, হ্যাঁ, ওকে, Positive হবে. Great. So unanimously everybody agrees it should be positive. Okay, so let it be positive from AVR. Okay, it is positive. Same condition, but tell me about AVL this time. Uh-huh. AVL থেকে you are looking at the train. ট্রেনটা অ্যাকচুয়ালি তোর দিকে আসছে না তোর থেকে দূরে চলে যাচ্ছে? তো তাহলে কারেক্ট, নেগেটিভ। এক্স্যাক্টলি, ভেরি গুড। তো দিস ইজ লিটল নেগেটিভ অ্যান্ড এভিএফ এর ক্ষেত্রে তো অনেকটাই নেগেটিভ। ডান, দ্যাটস ইট। নাও হোয়াট অ্যাবাউট দিস মেজর ভেন্ট্রিকুলার ডিপোলারাইজেশন? This time we will talk about major ventricular depolarization. So major ventricular depolarization direction was like this. So tell me about AVR. Correct. Okay, very good. So AVR should be of negative nature. So AVR should be of negative nature. Let's put it negative nature. What about AVL? AVL also away. So okay, so in case of AVL, it is okay away. But once again, a component which will be dropping towards AVL, সেটার অ্যারোটা কোন দিকে থাকবে? লাইক যদি এরকম যায়, আমরা সবসময় কনসেপ্টটা ওটা আমি বোঝানোর চেষ্টা করছি। মানে তুই দেখছিস যে একটা ট্রেন এইভাবে যাচ্ছে তেরছা হবে। আমি ওই জন্য বারবার বলছি যে ফার্স্টে অবজার্ভ কর কি হেড অর টেল। অনেক সময় এরকম হবে, ইফ ইট ইজ ডাইরেক্টলি পারপেন্ডিকুলার, চলো আই গিভ ইউ আইডিয়া। ইফ ইট ইজ ডাইরেক্টলি পারপেন্ডিকুলার মানে এখানে যে সিচুয়েশনটা হচ্ছে ট্রেনটা এসে বেরিয়ে গেল, তুই সাইড বরাবর দেখছিস। এরকম হতে পারে তো যে তুই সাইড বরাবর দেখছিস? ইয়েস। তো অলওয়েজ রিমেম্বার দিস, এরকম যদি কখনো হয় যে ট্রেনটা এসে বেরিয়ে গেল, তাহলে আমরা দুটোই ডিফ্লেকশন দেখতে পাবো, লাইক বোথ পজিটিভ অ্যাজ ওয়েল অ্যাজ নেগেটিভ, বোথ দ্য ডিফ্লেকশনস will be seen by us. So somewhere you can write this as well, that if negative okay, if negative charge or positive charge is moving towards first towards positive then away from the positive, it is moving towards positive then away from the positive, তাহলে গ্রাফটা না মানে ওয়েভটা এরকম টাইপের আছে, ফার্স্ট পজিটিভ দেন away from the positive। বুঝতে পারলাম কি পারলাম না? ওটার জন্যই আমি এই কনসেপ্টে যেতে যাচ্ছিলাম না মুখস্থ বিদ্যাতে। তো ওর জন্য আমি এটা বোঝানোর চেষ্টা করছি যে একটা কম্পোনেন্ট অফ এভিএল দ্যাট শুড ফার্স্ট, লাইক উইল ইট বি ফেসিং এভিএল অর ইট শুড গো অ্যাওয়ে ফ্রম এভিএল? কারেক্ট, প্রথমে ফেস করবে তারপর চলে যাচ্ছে। এভরিওয়ান এগ্রিজ উইথ দিস? তাহলে ফার্স্ট হবে, দ্যাটস হোয়াট আই এম ট্রাইং টু ক্লিয়ার আউট। এটা বোঝা গেছে কি? তাহলেই আমি সার্থক। তো ফার্স্ট there will be positive and then there will be negative। আচ্ছা, we are talking about which one? এভি, হ্যাঁ এল ঠিকই আছে, ওকে। We are talking about AVL, ওকে। আচ্ছা, what about AVF? AVF তো পুরোই পজিটিভ হচ্ছে। কারেক্ট, বড় পজিটিভ, ইয়েস, ভেরি গুড, বড় পজিটিভ হবে। এই ঠিক আছে। So this is about the AVR, AVF and the AVL. So fine, I'll give you 1 minute time. Acha, okay, let's finish it off. What about repolarization? Let's do something about repolarization this time. So repolarization wave should go in which direction? AVRA decay. And mind it, this is not electro. Correct. This is electro. Yes, this is electronegativity. So now tell me, it is electronegativity, and it is moving towards AVR. AVR is still anode, right? Very good. Total negative. Everybody agrees with this. Correct. So it should go negative. That means like this. This is AVR. What about AVL? Negative faster than positive হবে. So let me put it in this way, like this. First negative, then positive. And what about AVF? AVF is definitely positive. Agreed? So bus, now you know how to read the limb leads, all the limb leads, where negative deflection, where positive deflection, which one is more negative, which one is less negative, which one is moderate negative. You know everything. Yes or no? Tell me. Okay, fine, fine. Take 2 minutes. I'm here only. Everybody, let's take a 2 minute. Huh. AVFA direction negative. This is basically a negative deflection, and this is the side AVF side. কি আছে? On the AVF side, there is anode or cathode. Anode. তার মানে negative charge moving away from anode. So negative or positive? Negative charge moving away from anode should be negative. তাই না? Understood? Okay. So take 2 minute time, digest this fact. Okay. So in case of AVR only, you will see negativity moving towards anode. In rest all the cases, we see negativity moving away from anode. है ना? So that is why in only in AVR you will see कि there is negative inverted T wave, but in rest of the cases you will see that it is just like QRS only, positive. Okay. So because after this we will move into the final part, the chest lead. That is actually much easier. Still, first digest this fact. Chalo, I'll just give you another 2 minute time. Let's take a 2 minute break. Like, don't run away. Stay. It's not like really a break. There is no break for 2 minutes. Just 2 minute take, relax, and just gather yourself. Then we'll again begin after 2 minutes. Last 2 minutes, just go through the notes so that we can start with the chest lead. All right, everybody's here. Okay. Huh. So we can continue because now it is time. We will have to think about the chest lead. Acha, now tell me one more thing. We have got two situation. We have discussed about lead 1, 2, 3, and we have also discussed about another thing, that is lead AVR, AVF, and AVL. Do you know that there is something called as a unipolar lead and something called as a bipolar lead? So, what do you think? Both are unipolar lead, or something is unipolar and something is bipolar, or something like that? both limb leads. One is augmented and one is chest. চেস্ট করতে গেল ইউনিপোলারও হয় বাইপোলার হয় মানে ইচ্ছে মতো আগে ভাগে তাকে নাম আছে লাইক নাম আছে একটু ডাক্তারের মতো কথা বল আগে যেগুলো করলাম এখন যেগুলো করছি ইচ্ছে মতো প্রিন্সিপাল অনুযায়ী use করতে এটা কি কথা হচ্ছে উই হ্যাভ গট টু সেটস অফ limb leads one is limb leads and the other one is augmented limb lead সিম্পল অগমেন্টেডটা বাইপোলার কেন আর ইউনি হলে কি হতো Look, okay, look, let's once again keep it simple. Wherever you are having two electrodes, use of two electrodes, bipolar. Where you are having basically one electrode, unipolar. Simple. So if we talk about lead one, so lead one was created using two electrodes or it was created using one electrode? দুটো তো bipolar. Augmented leads, they used one electrode or they used two electrode? One electrode, তাহলে unipolar. Simple. Okay. So using this same concept, now we move ahead and now we are going to talk about the chest leads. Now I think this is going to be easy for you because you have already practiced it. Chest lead. Now, what is the concept of chest lead? Very simple. The concept of chest lead is key. If I go back to the heart picture, where is the heart picture? Yeah. Acha. Acha, okay, chalo, it's like too high. Okay, anyway, suppose I make a heart picture. Suppose this is the that schematic diagram of a heart. So we have how have we got it? One was this way, one was this way, and one is this way. Then what else we have got? We have got like here AVL, AVR, and AVF. These are two things that we have discussed. So, do you realize whatever you are discussing right now, they are all in the frontal plane. We are considering as if heart is a 2D picture. But is heart really a 2D picture? Definitely not. The heart is also need to be observed along this plane. Yes or no? Yes. So heart needs to be observed along this plane. So if we chop off somebody's personal heart, let's say in this way, like someone like this. Okay, if we chop off somebody's heart in this way, like this way, this is the plane. So do you realize this is going to be the somewhat the section that we will get? Huh. And using the similar old concept of Wilson's triad, we will consider the center to be zero. Agreed? Okay. That means this is zero. This is the zero position. Now my point is this: I want to check the potential difference between the center point and this point, 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 center point and this point. Tell me whether you understand it or not. So I want to basically check the thing between this and this and this and this and this and this and this. So tell, is it possible or not? তাহলে চেস্ট লিড শুড বি ইউনিপোলার or bipolar? ইউনিপোলারই হওয়া উচিত and হবে। সো দিজ আর অল ইউনিপোলার চেস্ট লিডস। তাহলে ইউনিপোলার চেস্ট লিডস এর আরো একটা নাম কি? ইউনিপোলার চেস্ট লিডস এর আরো একটা নাম হচ্ছে প্রিকর্ডিয়াল লিডস। সো okay, so we can call it as precordial leads or chest leads. Now, usually we number it like 1, 2, 3, 4, 5, 6. So usually V1 is placed at the right edge of the sternum. Okay, so this is the sternum, this is my sternum. So right edge of the sternum at the fourth intercostal space. So 1, then 2, then 3, then this is somewhere the fourth intercostal space. So sternum, the right edge. Then V2, this one is V2. So V2 should be placed just over here. That is left edge, same level, but left edge of the sternum, fourth intercostal space, but left edge of the sternum. Then next one comes up V3. So V3 is between V2 and V4. Now where is V4? V4 is present at the mid clavicular line in the fifth intercostal space. So this is the clavicle. So the mid clavicular line should pass like this. So if this is the mid clavicular line, then fifth intercostal will be somewhere over here. So this is V2 and this is V4. So somewhere in between. So that means somewhere here there is going to be V3. So then comes a V4. Then V5 is the anterior axillary line. So this is the anterior axillary line at the fifth intercostal only. So same level, but it should turn a little bit. So anterior axillary line, and V6 should go along the mid axillary line, same level. So nothing goes beyond fifth intercostal. So everything is finished between fourth intercostal and fifth intercostal. So fourth intercostal and fifth intercostal. So 1, 2, then 3, 4, 5, and mid axillary line is going to be 6, fifth intercostal. Understood? So these are the ways by which we are going to place the 6 chest lead to observe the heart from a horizontal view. So we are now going to observe the heart from the horizontal viewpoint. So I think now it is also going to be very, very simple for you, because now you are going to tell me that if you are looking from V1, observer is at V1. So what is your opinion? So V1 should be like in case of V1, what is happening? Here the depolarization wave is moving towards you, or it is moving away from you, or first moving towards you then away, or what is happening? V1. Very good. So V1, because we are thinking about the major ventricular depolarization. Okay, let me clear it out. I want to talk about the major ventricular depolarization. So let me draw the arrow also for you. So this is the direction. This is the direction of major ventricular depolarization. Yes. So, tell me V1, V2, V3, V4, V5, and V6. So, you tell me V1. So it is you are looking at the tail of the train, or you are looking at the head of the train? Tail. So negative or positive? Negative. Very good. So it is negative deflection. What about V2? Now in V2, you are seeing the absolute tail, or first you see the head, or first you see the tail, then the head, or first the head, then the tail? What is your opinion? You are standing here. It is going like this. So, correct. হেডটা দেখে তারপর টেলটা আসবে। Everybody agrees with this? All of you? Tell me. Okay. তাহলে first there should be like positive and then negative. Okay. So you tell me, you are looking at the head for longer duration or looking at the tail for a longer duration? When the train is going like this, so tailটা বেশি দেখছি, that means the positive deflection should be tiny and the negative reflection should be bigger. Yes or no? Okay, that means I can say tiny positive reflection and a bigger negative reflection like this. Okay, now V3. So V3 is like midway, midpoint. So can you distinguish that you are looking at tail for longer duration or head for longer duration, or it is equal? Almost. Equal almost. মানে positive reflection and negative reflection should look same. Like, so it should be like this, correct? Now talk about V4 this time. So in case of V4, what is happening? Now who is more, who is less? Head ta more, tail less. Correct. Head টাই বেশি দেখতে পাবো। So first deflection should be larger or second deflection should be larger? Correct. প্রথমটা বড় হবে and সেকেন্ডটা ছোট হবে। Agreed? Now let's talk about, this one is V4. Then let's talk about V5. So in case of V5, V5 is almost you have reached the front. This one was V4, and now you're in V5 almost. So V5 means almost you are in the direction, almost. I think the direction, if I have to draw it according to this diagram, then I think I should draw it in this way, a little bit, tilt it a little bit more, है ना? It's absolute left I have to do. So let me make it absolute left so that your calculation becomes easier. I have to shift it a little bit more. Huh. So V5, you're at V5. So V5, you're looking at like what? First head or first tail, or what is the situation? V5, train is going like this. Till now, you are seeing the head first and then the tiny bit of tail. But what is your take now? Parallel যাচ্ছে. Okay. But anode ta is facing the face of the train, mundi of the train, or the tail of the train. Correct. So that means deflection should be positive থেকে বেশি হবে, and V6 also similar, তাই না? So here actually we can put it in this way. Here initially a little bit of negativity comes up because first we see a tiny amount of tail, then we actually get to see the head. But okay, this is like making it too absolute. It goes like this, but fine. So this is the idea. See, check it out, whether you are getting or not. Everybody tell me, you have understood or not? Okay. So you see how the gradual change is taking place? See, V1 was completely negative and V6 is completely positive. And see how the entire transition took place. है ना? So, first negative deflection is always called as Q wave. How do we define Q wave? Q wave is the first negative deflection. Now, do you know that in ECG there is a difference between this and this? So, though there is no rule about it, but in general term, if we see that deflection is tiny, then we use small letter, we use lowercase. But if we see that the deflection is huge, then we use capital letter. Like here, I can say that this is first positive deflection, and first positive deflection is R wave. Okay, that means I can say this one is small r, and second negative reflection is not Q. First negative reflection was Q. Second negative reflection should be, see, this is your ECG, na? So if you look at the QRS complex, नीचे, ऊपर, नीचे. The first negative reflection is what? Huh? So always remember this. First negative reflection is Q, and second negative reflection is S. So here S is bigger. So what I will do is I will write it as capital S. Okay. In the next case, I will write both capital R, capital S because both are equal. So can you tell me in V4 what should I write? Very good. Capital R, small s. V5 it should be first negative deflection. Very good. Small q, capital R. Nice. And next one should be absolutely q. Sorry, absolutely R. है ना? So you see from an absolute q, how we reach till the absolute R. This was one was easier, I guess. I think in this no confusion should be there. That means don't worry, it is very simple. Okay, chalo, I'll just show you. So, acha, so V1, V2, V3, acha, it is, I have shown it already. So, V1 to V6, okay, if you also look at it, see, look at a pattern. This makes your life easier. So, if you look at a situation, let's say like this, we started, then we went like that, then we went like this, then we started from here actually. Okay, and then it became like this. So if you see, if you draw a line, do you see it is a escalating line? The line is moving upward. So this is the idea. So if you ever see any somebody's ECG where this line is not moving upward, you check out say chest leads. You have to check all the lines. You have to imagine over here that all the lines must be moving upward. So you should understand that okay, this one V1 this much, V2 this much, V3 this much, V4 this much, V5 this much. Line will move upward. Consider it is completely, absolutely all right. No confusion. Okay. Okay. So this is the idea of a functional ECG. This is how we check ECG. These are the concepts that we use in ECG. So let's talk about P wave. What have we learned? Key P wave, what should be the magnitude? How should it be present? Okay, we learned about the P wave. We have also learned about the QRS complex. In which case, what do you think? In all the cases, are we seeing that QRS is positive, or is was there any negative condition also? আছে, কারেক্ট, দুটোই আছে, ডেফিনেটলি। ওকে, সো আচ্ছা, by looking at so many waves, there are so many waves, what is our final conclusion? What is the resultant vector? We have to think about one vector na. Some vector is going in that direction, some vector is going in this direction, some, what are we trying to know over here? So let me give you a summarization, that what is the benefit of knowing so many things about this ECG. I'll just sum up this entire thing. So you should understand one thing is, suppose I have got, okay, let me remove this. We have discussed the chest leads here. These are the chest leads. Oops. So let me like summarize both the things, whatever we have discussed above and whatever we have discussed below. So let me draw a very, very simple heart for you. So this is our beautiful tiny heart. First thing first. First thing first is we have got situation one. Okay, we have got situation one, axis, which is lead one. I hope you understand. This is one. Then who can tell me what is this one? This is lead. Correct. This is lead two, moving towards the apex of the heart. And this one is lead definitely three. Yes, this one is lead three. This is the positive. This is the positive electrode. This is the positive electrode. So this is lead three. Then what else have we got? We have also got over here. This one was AV, R. Then we have got this one to be AV, L. This is a positive, no? And then this one should be AV, F. And then we have discussed one more thing. That is, if okay, if this is the horizontal plane of heart, then we have also discussed that there is supposed to be present V1, V2, V3, V4, V5, and V6. 1, V2, V3, V4, V5, V6. Correct? So, looking at so many things, what do we understand? So, we understand something called as a cardiac axis. Final axis. What is the axis in which the depolarization is taking place? So, cardiac axis is the net direction of depolarization. Okay, it is a net direction, final, like net resultant vector, net direction of depolarization. So remember, in a normal heart, okay, if you look at a normal heart, in a normal heart, the direction is downward and leftward. Okay, let's say the direction is what? Downward and leftward. Now you tell me, like, suppose I find that in somebody's heart, it is not downward and leftward, it is absolute leftward. What does it mean? The heart has, don't you think that the heart has swollen in this direction? That means having the direction going absolute leftward rather than downward and leftward, going absolute leftward. That means the heart has got swollen in, gone in this direction. The apex is in that direction. But how can the apex be in that direction? That means definitely it is the left ventricular hypertrophy. Yes or no? Tell me. You understood or not? Yes. So this is how we understand. So easy rule of thumb. How do we check it? So remember, if QRS, you have to simply do two things: check lead one and check AVF. lead 1 and AVF, because lead 1 is going to tell you the left side and AVF is going to tell you the downside. So simple concept. Check lead 1 and check AVF. If lead 1, sorry, if QRS is positive in lead 1, along with AVF positive, that means it indicates movement is in downward direction. ठीक है ना? So ideally, like suppose if I consider this to be the axis, like like that 0 degree, 30 degree, 90 degree, that hexaxial system that we have discussed. This is zero. Understanding what I'm talking about? This is zero, lead 1. Then this one was minus 30, then minus 60, then minus 120, like that it was going, na. This one was downside, I told you, na, last class. Downside positive, plus 30, plus 60, plus 90. So that way, this is what I'm talking about. So remember this, key, anything which is present between minus 30 till plus 90. So where is minus 30? This is minus 30. This is minus 30. Till plus 90. This plus 90. Anything between this area is normal. This is the normal axis of the heart. But this is the normal axis of the heart. Suppose somebody is there whose axis is like this, between this area. That means what is happening? If you look at the central picture of the heart, so the resultant vector of the heart is in this direction. Is it right or right for the person, or is it wrong for the person? Is it healthy or it is diseased? Instead of going leftward and downward, it is going rightward and downward. Is it? Of course, diseased. This is called as, so it is moving in which direction? It is moving towards the right hand side. So it is called as right axis deviation. That means if you see that like in lead 1, okay, so suppose in lead 2 and lead 3, along with AVF, the QRS is positive. Lead 2, lead 3, along with AVF, all of them has got QRS positive. And in lead 1, you, instead of getting the like Q wave, you get like a predominant S wave. Mane Q predominant mane bigger S wave. Like Q wave is tiny, S wave is bigger. S wave, remember, basal depolarization. Basal depolarization is bigger. So if in lead 1 the Q wave, S wave is prominent, along with that, if lead 2 and lead 3 and lead AVF, not lead, sorry, AVF, it has QRS positive, it indicates that the direction of the voltage is towards the right side. That means maybe right ventricular hypertrophy. Correct? And similarly, there can be a left axis. This is called as a RAD, right axis deviation. Then similarly, we can have a left axis deviation. See, this one, what is left axis? This is right axis deviation. This one. Now, what is left axis deviation? Left axis deviation is whatever is left. Left axis deviation occurs primarily in this direction. This is the left axis deviation. It's gone left to the normal. That means it is going in this direction. This is like absolutely abnormal, hai na? So what do we see? Like all the lower leads. See, it's common sense. All the lower leads bolo to lead 2 and lead 3. Lead 1 is not a lower lead. Lead 2 and lead 3. They will pick negative QRS complex. Of course, AVF will also take up negative QRS. All the lower leads. AVF is also a lower lead. Lower lead, na? So they will pick up negative QRS complex. And along with that, in lead 1, you will get the R wave predominant. That means that R wave wala vector is also moving towards lead 1. Mane everybody's arrow is directing upward or downward? Upward. So tell me everyone, have you understood or not? that final result what we get by reading all these ECG. Okay, rest of the people. Okay, definitely to revise a little bit. So remember this, as a whenever you get a ECG to read, okay, whenever you have somebody shows you some ECG, so don't just dive into it, because there are so many things that we can actually derive from here. So if you just like keep jumping around, then you will have a tendency to miss out a lot of things. So keep yourself cool and calm, and try to understand that what are we going to check. So I'll give you a rule of thumb, very simple, that whenever you check out ECG, so first thing that we can check, that is the person's heart rate. Simple, by checking the QRS complex, है ना? Check out the RR interval. Okay, tell me, if I check somebody's personal RR interval, how many RR intervals are there? Then don't you think I will be able to, in a minute, how many R waves have come up? Don't you think I will be able to tell the heart rate? So I can check the heart rate. Can you check whether the beats are regular or not? Or whether it is taking time, abrupt time, regular, irregular? We can check. দেখা যাবে. Second thing, we can check the wave, just what we learned today and last class. Waves we can check whether the waves are okay or not. Correct? We can check all the QRS complexes. We can check PR interval. How can we check? I'll tell you that. PR interval. Okay. Of course, just now I taught you we can check the axis. Okay. So these are certain things, because these things will tell us whether there is any hypertrophy, whether there is any infarction. All these things they will tell us. So we can check how many? One, two, three, four, five, six. These are six things that we can actually check about it. Okay. So and you understand each of them, they're pretty important in diagnosis. So it's very, very simple. It's not that difficult. So in practical reality, next time you get a ECG paper, so I'll tell you how to deal with it. So suppose there is a ECG paper, है ना? I'll tell you, the calibration, your job becomes very easy. This is ECG paper. Now what happens is, in ECG paper, there will be some. It's like a graph paper, है ना? So suppose I draw a graph paper for you. So let's keep it simple. 1, 2, 3, 4, and 5. So I'm making a graph paper like structure 1, 2, 3, 4, and 5. So remember, every minute it will roll 300 such squares. Okay, there will be 300 such squares going in 1 minute. That means 300 squares are crossing in how many seconds? In 1 minute, 300 squares will pass. That means 300 squares are passing in how many seconds? 1 minute is equal to 60 seconds. Na? I'm asking 300 square will take how much time to pass? 60 seconds. Na? So now comes up the real question, that one square will take how much time to cross? 5 seconds. It should be 60 by 300. Na? 300 square in 60 seconds, unitary method. So one square is 60 by 300. Na? So it's supposed to be, I think, 1 by 5. So it's supposed to be 0.2 second. है ना? That means what you have to understand is कि this depicts 0.2 second. Okay, and also remember one thing कि this depicts 0.1 millivolt. Clear? Now, one square again has got five tiny squares in it. Okay, one square will have one, two, three, four, five. One, two, three, four, and five. Got it? Tiny squares. So that means if I talk about these purple squares, so you tell me now, these five small squares are taking how much time to cross? These five squares are taking how much time to cross? No, no, these are five small squares, tiny squares. One big square is taking how much time to cross? And one big square is equal to how many small square? One big square is equal to how many small square? One, two, three, four, and five. है ना? Look at the time. Time is going in this way, and this one is going for the voltage. So when I'm saying time, when I'm talking about time, so five square will take how much time to cross? Machine is running. So how much time it will cover this big square? I think this is the easiest question of the millennium, and nobody could answer it. It's a simple trick question. Actually, a sort of a common sense based question. So think, huh? Exactly. So five small square, where the rest of the people are gone or what? Acha, okay. So five small square is going to take 0.2 second. So that means one small square will take how much time? Very good. So finally somebody is still fighting. So 0.2 divided to 5. So I think if you calculate it, so 1 square is equal to 0.2, it's going to be 0.04 second. So, okay, so this is going supposed to be 0.04 second. 0.04 second. So one thing, let it be very clear. If you have two and a half square, that means 0.4 plus 0.4 plus what should it be? Half. Half minus 0.2. Correct. 0.1. So why am I telling this? Because it will make your life very easy. Because P 0.1 second, normal I'm talking about. PR segment 0.1. Remember this. QRS 0.1. Okay. QT. Now QT is also very simple. QT is 0.4. QT is 0.4. 0.4 means how much? 0.4. Mane, see, one big square is 0.2 Correct. Duto big square. That means that is the whole ventricular depolarization. It's a big thing. It will take a lot of time. Okay, so this is the sorry QT. So understood this? Why I'm talking about two and a half small square? Because when you check, if you follow the two and a half, two and a half, two and a half, two and a half rhythm, your job becomes very easy. So, but remember, this is some students they do get confused. I said PR segment. PR segment. See, segment is different. Remember, if you include the wave, see, between wave 1 and wave 2, between the two waves, this is called as the segment. And if I have wave 1, wave 2, and I want to know the duration inclusive of both the waves, then that is interval. Got it? Okay, okay. Don't worry. I'm there. I'll explain. Suppose this is our wave, okay? This is in this, so there is no confusion now. Now you know all the details of it. So every galvanometric deflection is called as a wave. What is a wave? Every galvanometric deflection is called as the wave. So purple ones are all waves. These are all waves. So these are wave. There are three terms. These are wave. Next thing, the duration between the wave. Okay, two waves are there, and I'm talking about the duration in between the two waves. So duration between the two wave is going to be called as interval. Yes. Okay. So remember this that I'm so sorry. I just told you the reverse. Sorry. It is called as the like in between area is called as the segment. Sorry, segment. It is called as a segment. So blue line is supposed to be called as the segment. And my brain is also getting so this area, the green area, this is supposed to be the segment. Got it? So isoelectric, this is called as isoelectric line. So isoelectric line between in between the waves is called as segment. This is the segment. And if I consider wave plus segment, this area, wave plus segment, wave plus segment, okay, or segment plus segment, okay, wave plus segment, these are called as interval. That means, suppose, or it like interval can be wave plus wave also. This one, wave plus wave. So wave plus wave or wave plus segment, that is called as interval. Okay, that means if I say PR segment is which one? This one. This is the sorry. This is the PR segment. But if somebody asks you what is PR interval, that is not this one. That is this one. Yes, this is the PR interval. This one is interval, not segment. Why I am being so particular about it? Because the meaning changes. See, somebody talking about PR segment, mane the person is talking about the nodal delay. But if somebody is talking about PR interval, that means the person is including SA node firing leading to atrial depolarization and AV conduction just before ventricular depolarization. The entire big story is there in interval, starting from SA firing just before your AV firing, the entire story. But if somebody talks about PR segment, they are only talking about the nodal delay. So the meaning changes. So when people say QRS complex, what do you think it is supposed to be? Instead of calling it complex, it is supposed to be what ideally? It should be QRS. It's collection of wave. So wave plus wave is so actually we can call it QRS interval. Okay. And what about this one? This one is QT interval. Actually, QT interval is from the beginning of the ventricular depolarization. So, bole to, it is supposed to be from here. Like I have to extend it a little bit from here. Actually, this one is QT interval. Q intervals will always include the waves. Understood or not? Now is it confusing? Got it, everyone? Okay. So now I think you are thorough with the basically a little bit of Kam Chalao idea of ECG. Correct? And now we are eligible enough to discuss each of the cardiac diseases. And if now I think if I correlate each of these cardiac diseases along with the ECG, I don't think there will be any trouble. You will be able to correlate, or at least if I explain it, you will understand it. Okay, fine then. Let us stop over here today. Okay. Good night. Bye bye. Good night. Good night. Okay, so a lot of people have messaged here as well. Okay, thank you everyone for watching.